All right, when evaluating rational exponent is just a fancy name when we see fractions in our exponents. And we need to remember, when we see fractions up there, what does that actually mean? Because fraction exponents are going to be equivalent with radicals. 16 to the 1/2 is the same as the square root of 16. These mean the same exact thing. Where that 2, the denominator of a rational exponent, always becomes your little index of your square root or radical, and the numerator always stays as the exponent. So if we wanted to rewrite 2 to the 3/4, the denominator always becomes the root of the radical. The numerator stays as the exponent on that base. So when asked to evaluate an expression like this, you first need to take your rational exponent and rewrite this as a radical. Since this entire expression is in parentheses and has that exponent, I'm going to put that whole entire thing underneath the radical. Now remember, the denominator becomes your index, so this is a cube root problem. Your numerator stays as the exponent on that base. Now we need to El Chapo this. Now technically, with this whole expression squared, that means 216 times m to the 9th is technically happening 2 different times in here. That will matter later for us. For right now, I'm going to ignore that 2, and I'm just going to El Chapo and reduce 216 m to the 9th. Now remember, your index over here has a huge role in how you reduce this down. This tells you how many factors need to be in one group for El Chapo to escape. So let's start breaking this down. So you break down the number as far as you can all the way down. And then remember, you can expand m to the 9th as just 9m's. Now, since this is a cube root problem up there, that's a 3, I know that I need 3 of the same factor in my groups when I'm reducing. So I see I have a group of 3 2's, I have a group of 3 3's, and I have 1, 2, 3 different groups of 3m's, okay? So that means from this, 1, 2 will escape. From here, 1, 3 will escape. And when multiple things escape, we multiply them on the outside. And then 1m from each group over here will escape. So I'll end up having m to the 3rd power. So 6m to the 3rd power is what escapes and is what is reduced from this expression. But now remember, how many times does this happen? Twice. So we reduced it once, but we know that technically we're going to write that answer down here 2 different times, since technically that expression up here was squared. So that answer is going to escape twice. So our actual final answer will be 36 m to the 6th power. To start evaluating and getting an answer, we need to take our rational fraction exponent and rewrite this as a radical. The denominator is always the index of the radical. The numerator will stay as the exponent. And since this entire expression is in the parentheses with this fraction, 32x to the 10th will all be still to the 3rd power. So technically that means 32x to the 10th is happening 3 full times. But I'm going to be strategically lazy. I'm just going to reduce 32x to the 10th and know that answer happens 3 times. That 5 out here tells me I need 5 of the same factor for 1 to escape. So let's break these down. So break down the number, break down the variables as far as you can. And remember, your index up here tells you I need 5 of the same factor. So 1, 2, 3, 4, 5. Need 5 of the same factor for only 1 to escape. So I'm going to circle groups of 5 this time. I see I have a group of 2, so 1, 2 will escape. I have 2 groups of x's, so I'm going to have 2 x's escape. But remember, this happens not just 1 time, it happens 3 times. So I still need to do 2x squared to the 3rd power. So that's like we still have 3 of those to multiply. 2 times 2 times 2 is 8. X squared times x squared times x squared is x to the 6th. And that's your final answer.